Hey folks, I just wanted to take a few minutes to give you a bit of a kind of common sense introduction to Git and to Make. This isn't something that I'm going to test you on for the course, it's not something that you're required to know, but it might make some things make a little bit more sense in the labs, since behind the scenes we are actually using Git to distribute and collect your labs, and we're using Makefiles to automate that to a degree. And later on in future courses, you'll be using both of them in much greater depth. So I just wanted to give you a bit of an intro to what these things are and to how they work. So the idea is that the Make program that we've been using is essentially a tool to automate some tasks. Now, for the most part, Make is used in the context of building programs, so kind of automating the compilation process, but it can be used to automate almost any sort of set of Linuxy tasks you want to work with. So in the case of 160, I've provided a set of files that allow Make to automate the lab kind of retrieval and submission process, and to automate the lab and project compilation process. And so that's kind of what I wanted to run through today, is how those make files are working and how they're making use of Git, which is the version control system that keeps track of the changes in your lab files and your project files. So Git is a version control system. Again, it basically lets us keep track of modifications to collections of files over time. So essentially, it can allow us to take snapshots of what all of our files in a directory look like at any given point in time. And then in the future, we can go back and look at when we made changes to the files, what changes we made. We can revert to certain versions of the file if we want to. You know, if we had it working and then made a bunch of changes and broke it and we want to go back to the working version, we can do things like that. So this is essentially the idea behind Git. And we've kind of expanded it in CS to make use of kind of some additional scripts so that you can get your labs and submit your labs through various Git commands. So I just wanted to run through kind of the basics of that for a little bit. All right, so we'll tackle Makefiles first. And again, Make is just a program that is sitting on our systems that is used to automate commands. So essentially you type in make and then something that you want to create. We'll refer to it as a target, the thing that I want to create or the thing that I want to generate. And then the make program looks around for a file with instructions that tells it how to build that thing, how to create that thing, how to generate that thing. So for every make program, there'll be some file that it looks at, and by default these things are just called Makefiles, so that the name of the file is actually Makefile. So when you run the make program, it looks in the current directory and says, okay, is there a file in here called Makefile? If it is, hopefully it's got the instructions inside it that tell me how to build the thing they want. So in the case of your labs, what I've done is in each of the lab directories that you have, if you look in there, you'll see something called a Makefile that has the instructions on how to compile that particular lab and how to submit that particular lab. So when you type in make, it just goes through and compiles the program for you. If you type make submit, it goes through and generates and turns in the lab for you. So each of these commands has a bunch of information inside the Makefile associated with it. It's got a target, right, the thing we want to build or generate. It's got a list of the files that it might require. These are called dependencies. We won't make too much of a use of that, but we will see it crop up a little bit. And then the actual sequence of commands to run to create the thing. So when you're sitting in the correct directory, you type in make and then whatever the thing is you want to build, and it goes off and creates it. So again, if we let's go into, so let's say the labx1 directory, for instance, that we've created. If you look around in there, you'll see you've got a make file. And if we take a look in that make file, again, you'll see that it's got targets, the things we want to be able to build. So if I type in make labx1, it will run this compilation command. If I just type in make and hit enter, then by default it looks at whatever the first thing is and tries to do that. So if you just type in make and hit enter, again, it'll build labx1 in this case. So the dependency list is the file that it needs to build this thing. So to create labx1, it needs labx1.cpp, right? So you have to have edited your .cpp file or brought your .cpp file up to date. And then to actually build the thing, it runs this g++ command, which should look pretty familiar, right? The g++, our warnings flags, the file we want to compile, and then the name of the executable we want to create. On the other hand, if you type in make submit, it looks in here, sees submit, and says, okay, I can figure out how to do that. There's no files listed here for it to depend on, so it can just go ahead and do it. And then it runs this sequence of Git commands. And so this Git Add is basically just going through and saying, okay, well, what I'll do is add in all the changes to the files in this repository. So essentially it's saying anything that you've updated, I'm going to keep track of. This git commit essentially takes a little snapshot of what all the files look like right now. And then this git push command is a git command to go off and send all of those changes back to wherever this stuff came from, which is the repository that I created for you when we were using our make-f, make160, blah, 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 blah. Now, we'll take a look at that one in just half a sec. But this is the idea. The make files are just collections of commands that say, okay, if the user says make something or other, look around to make sure that these files exist, and then run whatever commands it is to actually do the compilation or to do the submission. And so if let's go and take a look at that make160 file that we talked about early. So in this one, again, same sort of idea. It's got a bunch of different targets. If I want to make csci.160 labx0, then it goes through and runs the commands to do that. So it goes through and this command creates a directory for your labx0. It goes through and this fork command is what goes off to the csci git server and creates the initial version of your lab. So this is essentially a version that I can see over on a server someplace. And then it copies that. So this git clone is going off and copying that material into your local directory to work on. So we can go through and actually, when we type in our make, and then by default it looks for a file named makefile with instructions, we actually want to use this make160 file. So that's where that command came from back in our very first lab, where we said make and then a -f, make160. We were telling it, okay, I want you to run make, I want you to look in this file for the instructions, and then I want you to create the labx0 or labx1 or whatever it might be. So this is where all that stuff is coming from. All right. So we've got make and the make files that we've been playing with. And again, this is kind of running through the things I've been discussing. We have the make file in our home directory with instructions on how to create the different projects, the different labs. And again, we just took a look at this. We just took a look in our make160 and saw the commands to create a particular lab. Now, feel free to have a look at your make files, but I really don't advise modifying them at this point, just because if you break them, then you won't be able to either get or submit your labs. And then again, this is running through the material that we just looked at for inside the labs themselves, where if we type in our make or make labx2, for instance, it looks in the make file, sees the instructions for labx2, says, okay, I'm going to need to make use of labx2.cpp, and here's the command to build the executable from the .cpp file. Or if they type in make submit, here's the commands to actually go through and do that using Git. And again, Git is just keeping track of the collections of files in one of our directories. Git terminology just refers to them as repositories. And it allows us to keep track of the different states of all of the files at different points. So essentially these commits that we do are just taking a quick snapshot of what everything looks like right now and saying, okay, I want to be able to remember this point and be able to come back to this point later on if I need to. So from that point on, the programmer can use Git commands to say, okay, remember what changes I made to a specific file, and these are where the Git Add commands come in if you're looking through that make file. Or to create a snapshot, to create a checkpoint, that's where the Git commit commands come in. Or to go through and make a working copy of one of these repositories. So to, for instance, copy the stuff that I've posted on the central server into a place in your account where you can work on it, you'll see Git clone commands, and that's just going through and making a copy. Checking for changes from one repository that we want to bring over to our own, the one that we've cloned. So this is where you'll see Git pull command, so it's pulling changes from one place to another. Or sending changes back to the original, and this is where the submit process comes in. If we do a submit, it does a push, Git push, which sends the changes we've made back off to the central version someplace. So Git, again, is meant as a version control system, but we're using it for a little bit more than just that. Now, all I've done here is to give kind of the quick thumbnail version of what these things are doing. If you want to see more details on it, again, particularly from our computer science department point of view, the way it works for us, I've got a kind of a guide to the way the Git submit process works, and so you can understand a little bit more about the commands you'll see in those make files, and a video that goes along with that. And again, these are the kinds of things, this focuses on the kinds of things you'll be doing in later courses to get and submit labs using Git. And then if you want more information on the makefile side of things, we get into it in a lot more depth in 265. So again, there's a video and some the slides and whatnot if you want to get into that. And of course, there's a ton of good resources on the web that are more generally focused on Git and more generally focused on make and makefiles. But that should hopefully at least clear up a few bits and pieces about what's happening with Git and with make. And that's really all I wanted to accomplish for this one. Okay, I will leave that there.